Hey there, this is 525 Z-score practice in relationship to section 5.5. I think you can probably turn off the video, do it yourself, and either check the answer key or come back if you can't figure out your mistakes. So we've got some straightforward Z-scores, a word problem, and this one at the bottom actually was pretty cool. It's working backwards. That one, if you got that right without my help, I am impressed. If you tried it without my help, good job. Okay, anyway, so turn off the video. All right, welcome back. All right, we need to calculate our Z-scores. So Z is equal to X minus mu over sigma. Z-score is equal to, all right, so here's my mean. My mean is my mu, and this is my sigma. So the only other number left, right? I don't know where to put this stuff. Well, if you know that mean is mu and standard deviation is sigma, 42's got to be the other number. And it says find the Z-score, so this is the one we don't know. So 42 minus 45 over 7. 42 minus 45. I can't believe I just did that. It's minus 3. So Z is equal to minus 3 over 7. I'm going to divide that out. Negative 0.43. I didn't tell you how many decimal places to use, but let me just do that now. Round. And it's key, really important in this section, that you round to decimal places. Okay, so it was 428, and the 8 makes the 4 go up by 1. And there we go. Now, like I said in the last video, the most common mistake people make is errors. So I just want to make sure that my number that I'm talking about is less than the mean, because I had a negative answer. Or you can do it the other way. If the number I want is less than the mean, I better check to make sure that's a negative down there. All right, we have find 3.8 if the standard deviation. Okay, so this is sigma, and the mean is 4. That's my mu. So Z-score equals X minus mu over sigma. Z-score 3.8 minus, what's my mean? 4 over 0.6. 3.8 minus 4, negative 0.2 over 0.6. Okay, and before we go any further, my value I'm worried about is less than my mean, so the negative is okay. Whoops, and I lost my Z equals. Divide by 6. Negative 0.03. All right, and you know what? I'm going to put SD, standard deviation, just to remind you that that's what it's about. We're calculating negative standard, in this case, negative standard deviations. Ooh, and then I gave you a question that looks all mathy, but I think it's way easier than the other ones because I'm telling you exactly what all the bits are. So. Formula. X, let's see, X is 10.3. Oops, minus my mu, which is 12.5, over 3.2. All right, it looks like I did it again, where the value I want is less than my mean, so I know it's going to be a negative, and that's okay. $10.3 minus 10.5, negative 2.2. Over 3.2. Negative 0.6875. Whoops. I said 2 decimal places, so negative 0.6875. 0.69. Oh, I don't know if you can hear my co-host. She's dreaming. All right. Hope you guys can see that. I think I will fix your sheet so that that's typed in as opposed to squinting your eyes like mine. At which location was Haley's run time better when compared to the club results? So we're running in Vancouver and Lake Louise. All right, so the mean, never mind, we're doing a Z-score. Okay, when you want to compare things, and this is the sheet that says Z-score practice, so Z-score equals X minus mu over standard deviation. All right, so Vancouver, her time was 24.95 minus the mean, so that would be the club's time, 25.75 over the standard deviation, 0.62. $24.95 minus 25.75 negative 0.8 over 0.9. That doesn't look nice. 0.62. All right, so negative 1.29. Standard deviations. Oh, like Louise said. Sorry, I just realized sitting there like this makes me look like I'm really bored. No, I love math. All right, her score 24.77 minus the club's 25.57 over club 0.60. Z-score 4.77 minus 25.57 negative 0.8 or 0.6. Negative 1.33. All right, so which one was she better at? What do you think? Well, I was thinking we could draw a graph. Yeah, let's do that. I'll go through two sets of reasoning here. Okay. If there's my mean, okay, so there's minus 1. So negative 1.29. Where would negative 1.33 go? Is it going to be on this side or this side? Oh, yeah, right. It's going to be here, more or less. Negative 1.33. So if we're looking at time and we want to be faster, then this is actually the faster 2 times. So she is faster in Lake Louise. Or, kind of some indirect reasoning, if I'm looking at marks where I want high numbers, I want to be as far this way as I possibly can. The farther I am this way, the better I'm doing. Well, this is running and I want to be lower. So probably the farther I am that way, the more negative I am, the better I'm going to be. Either way, Haley was better in Lake Louise in comparison to the rest of the team. All right, let's look at some Newfoundland dogs. You guys ever seen those things? They're like huge. Oh, I'm going to tell you a story. I'm going to tell you a story. Very first job, I did Census for Canada, Census Canada. And that was back in the previous century when we actually delivered the census data booklets out to every household. Well, I had a farm route and I was out on a farm and I was putting it in the mailbox. They're actually dropping it off at the house. And I heard this big old woof. And it was a Newfoundlander. And he wasn't happy that I was on the property. I sat pretty much on those doorsteps for about half an hour until the farmer showed up. Dog didn't hurt me. He just sat at the bottom of the steps, and every time he moved, he went woof. And I decided I was just going to sit there and hang out and not be eaten by the big dog. He's a lovely dog, but big dog. Anyway, just a random little story to entertain you in math class. That's what it's like when you're in my classroom all the time. I will just randomly break into stories that may or may not have anything to do with class. Just breaking it up, adding a little spice to your life. Okay, Newfoundland dogs have masses that, oopsies, lost a letter there, are normally distributed with a mean of 63.5 kilograms and a standard deviation of 1.5 kilograms for male. Ooh, what mass would correspond to 1.8 standard deviations below the mean? Okay, you know what? My brain's going, nope, nope, nope. Don't know how to do that. That's kind of scary. So what am I going to do? I'm going to draw a picture. Any of these set scores, if you get remotely lost, draw yourself. You have a mean and a standard deviation. So you always have enough information to draw yourself a curve. Oops, there we go. There's my mean. Sorry, I didn't do too good on symmetrical this time. All right. Frequency. All right, and we said the mean is 63.5. And we're going to go up by 1.5. And we're going to go down by 1.5. Symmetry, it's all about symmetry. All right, 63.5, oops, plus 1.5. It's going to give me, you see that? Yeah. All right, 66.5. I did it wrong. I know what it is. 65 plus 1.5 would be 66.5 plus 1.5, 68. Um, 63.5 minus 1.5 gives me 62. Nope. 60.5 minus 1.5, 59. All right, we want to know what mass. So this time we're actually looking for the number that goes across the bottom that corresponds to negative 1.8 standard deviations below the mean. So there's my mean. I want to go 1 standard deviation. And then I want to go, right, so below, so I'm going to the left. I'm going to go 1.8. So I'm going to guess this is an estimate. So if that's 60 and that's 62, I'm going to guess, as I should say estimate, about 61 kilograms. Now I'm going to do my question, but this part is just to help me so I know about what it is. I also could have done the estimate after to see that my answer is reasonable. But I know I'm going to talk about a z-score because I'm talking about standard deviations. So z is equal to x minus mu over sigma. Now, what do I know? I know the mean, right? The mean is 63.5. Whoops, let's put that in the mean spot. And it says a standard deviation of 1.5, so that's sigma. Now, I have one more number left. It's 1.8. Now, is that the mass of the dog? Or is that the z-score? Well, I would hope you would think that that can't be the mass of the dog. So 1.8 must go here. And then this must be our variable. Besides, if you put the 1.8 there and use the 63.5, I don't know what would happen, but you get some huge number and it shouldn't make any sense, right? Because your z-scores, remember, have to be between -3 and +3. Speaking of which, if this is a standard deviation below the mean, guess what? That should be a negative. So how are we going to solve this? Well, you know what? This is a fraction. Let's make this a fraction. You know I am a fan of cross multiplying. If you've remotely watched any of my videos, you know I like cross multiplying. So 1 times x minus 63.5 is going to give me -1.8 times 1.5. So 1 times that just cancels out and my brackets disappear. And 1.8 times 1.5 is 2.7. So, okay, I know I didn't use a negative on my calculator. It bothered me. It's just, I don't. But I know it's going to be a negative 2.7. Now I'm going to add 63 and add 63. 63.5. Yeah. Now I'm going to have to make a negative. Negative 2.7 minus, whoops, nope. Should have just done it properly. Negative 2.7 plus 63.5 is 60.8. So x well, when I did my guessing over here, I said it'd be about about 61 kilograms, and it turns out to be 60.8 kilograms. So that's pretty close. And by the way, if you had missed this negative here, this would have been a positive, and this would have would have ended up adding these two together. So let's just hold on for a sec. 63.5 plus 2.7. You would have got an answer about 66, somewhere over here. Okay, so that's another reason why drawing that curve is going to help you. It will catch you if you make a sign error. Okay, or even if you had that answer of 66, you should look at it and go, but I'm supposed to be below the mean, and the mean was only 63, so 66 is too big. This is a lovely answer because it is below the mean. All right, sorry for my very messy worksheet, but I'm hoping you're digging this because it's kind of cool.